Hello everyone, how are you guys doing? I hope you're all doing amazing. Team is speaking in from the corner today, and the problem we are solving is best time to buy and sell stock 2. Now in this problem you are given an integer array prices where prices I is the price of a given stock on the ith day. And on each day you can decide to either buy or sell the stock, and you can hold it at most one stock at a time. And finally you want to return the maximum profit you will achieve from this. Now we just did a very similar problem to this. In fact, actual predecessor to this problem, which is best time to buy and sell stock, where we can only make a single transaction, but this time we are allowed to buy and sell multiple times duration in the duration of our array, which represent different days. So how can we go about that, and how is it different from the previous problem? Well, the first difference we observe is the fact that it's a LeetCode medium problem and the previous one was a LeetCode easy, but that's not the real difference. Let's just see how we can solve it differently. So you're given this array 715,364, and you finally want to return the maximum profit, which is going to be 7 in this case. And how do we get to 7? Well, if you buy on the second day and you sell on the third day, you will earn a profit of 4. And if you repeat that process and you buy on the third day and sell on the fifth day, you will again earn a profit of 3. And you will end up with a whopping profit of 7. That's amazing. Good for you. Well, so that's the problem. Basically, you can do multiple buy and sells, and you finally want to return the maximum profit you can achieve from this. And let's take it to the whiteboard and see how is it different from the previous problem and what approach will work for this one. And in this video, we are going to again solve this problem with two different approaches, where our first one is going to be extremely simple and based on observation in this problem. But the second one is going to be a little bit more tricky, and it can be a quite a difficult thing to understand. And I also think it's more of an overkill for this particular problem, because that pattern is very widely accepted in LeetCode, but at the same time this problem is too simple to fall in that range. But I want to discuss that solution because, as I just said, that pattern we are going to be using for solving this problem is very widely repeated in LeetCode problems, and you can find them in interview problems all the time. So I think this video is a good introduction for it as any other video. And if you have not guessed it by now, pattern is dynamic programming, and stay tuned till the end of the video to actually see how we can solve this problem using those concepts. So let's write down our array first without any further ado, which is 715,364. We finally want to return 7 from this, and how can we go about doing that? Now, in the previous problem, we were able to use a two-pointer approach, because we can only make a single buy and sell transaction. So we basically put in the problem as we 2-point selection problem. So basically we transform the problem to a maximum profit finding problem to a 2-point selection problem, where we want to find the 2 points where we get the maximum difference from. And we were able to use it using 2 pointers, and it was completely straightforward. If you have not watched the video, go ahead and watch the video and see how simple it is. But in this case, you can have multiple 2-point pairs, and in this case, for this particular solution, you have this as one pair and this as another pair, and you have to somehow include all of these pairs to return the max profit. So how can we go about doing that? Well, two pointer actually doesn't make sense, because there is no limit to the number of pointers you can have. You can make as many transactions as you want, so you can have multiple such 2-point pairs. So 2-point solution is out of the question. So what else can we use to solve this problem? Well, when you're stuck like this on problems and can't think of any good solution, one way to think about them is by using the different circumstances that can occur. Well, let's see what all can happen when we are traversing a array. Well, we can observe values that are going from higher to lower. That's the first case, where our value is decreasing. The second case is when our value is increasing. And the third case, or like a bigger pattern in this picture, would be like if the value keeps on fluctuating. So we have three different cases. Either our value keeps on increasing while we are traversing the array, or our value keeps on decreasing as we are traversing the array, or the value keeps on fluctuating at each point. Now let's try to draw a graph for this particular problem given to us and see how can data visualization help us here. So we are given an array, and let's try to draw this. So your 7 will be somewhere around here, and it's not going to be up to sale, so sorry for that. And your 1 is going to be somewhere around here, I guess. Fine. 5 is going to be closer to 7, and somewhere more forward on the third day. On your fourth day, your value is 3, so you put in somewhere around here. Then you have a value of 6, somewhere between 5 and 7, and 4, which will be somewhere around here. So this is what your final graph looks like for this problem. So this graph particularly lies in the fluctuating problem. And how can you make the maximum profit out of a strictly increasing, strictly decreasing, or fluctuating pattern? Now, if you see here in the fluctuating pattern, you can see that whenever you buy at a minima and sell at a maxima, you can accumulate all of those local minima and earn a maximum profit. But in cases where it's strictly increasing and strictly decreasing, you would might be thinking that it's better to buy at the sell to the peak and buy at the low. Well, that intuition is not particularly wrong for the stock market because each transaction costs you something. But if you think of it in this particular problem, you can see that even if you buy here and sell here, uh, or you buy at each step on your way towards this continuously increasing value, you will end up with the same profit because your height is always going to be same anyway, so your profit is going to be same. And we can observe it here as well. So you see that you use this local minima and then you use the difference between these two local minima and maxima and you earn your maximum profit. So basically what you are trying to do is buy low, sell high at each step. Well, that's the fundamental of stock market, and I think it makes sense after seeing this problem. And yeah, that's your solution. So basically, you want to go through all of the array, and you know that you're only going to make profit when your sell is actually higher than your buy value. So you're not going to do it here, and you want to maintain a maximum profit, which will actually correspond to your difference between the next value and the previous value if their difference is actually positive. And that makes sense. We can see all of the three cases that whenever we are increasing, we want to buy there because we know in any case whether the value goes down from here or up from there, we will be able to make the maximum profit in our next runs by buying and selling there. So wow, the problem just turned into a greedy problem, and greedy problems are the simplest to code. So let's go back to our LeetCode and write the code for this. And I hope the solution made sense. It's extremely simple. It's just based on data visualization and some kind of condition observation where you try to see what all different circumstances can occur while you are traversing the array and how will they affect the decision if they actually will, which in this case they don't. So yeah, let's go back to LeetCode. Let's try to code it up. So as I said, you're just going to maintain a variable which is going to store your total sum, and you're going to traverse the array starting at 0, and you want to keep going till you hit len nums, not nums, prices. Oh my god, the first couple of videos made such a bad habit on me. And then finally you're going to keep iterating it till your second last element. Now why do I say we only iterate to the second last element? Because we don't want to make any buy or sell decision here. If you have come here, you have already made all of your decisions. You can sell here, but your selling is taken care of at the previous step only because you always look for the patterns where your sell value is higher than your buy value. So you're always iterating the array in +1. So you're always comparing the ith value to its I plus 1th value to see if the stock is worthy buying right now or not. So that's exactly what you're doing. So that way we only want to traverse to the second last element, and the simpler way to understand it would have been that you would run out of your indices if you check for I plus 1 here. So you don't want to stock here at that point. So in this case, you're just going to check that if your price is I plus 1 is actually greater than your price is I, you are just gonna add it to your total sum and say that your sum is plus equal to I plus 1 minus price is I, and then finally you can return your sum. So as I said, only 10 lines because, and we're gonna get rid of one of them, so only 9 lines because it's a greedy solution and greedy solutions are always super simple to code. So, oh, and we got a compile error. Wow, that shouldn't have happened. That's because of the space. I don't know why I did that. I tried to fix it, but then my keyboard get up again. Cool. So the solution is accepted. Let's try to submit this and see if it gets submitted. Okay, so the solution is submitted. I hope Pingo is happy as well. Now let's go on to the second solution, which is a little bit of a overkill and it might be a little bit difficult to understand, but I'll try my best to explain it to you. So let's get straight into it. We are able to beat 100% in runtime here and 81% in memory, which is good. We are only using a single variable as a memory, so it's the best we can do. I mean, we can't do any better than that anyway. So now let's think of another solution. Well, you have to make buy and sell decisions while iterating the array. So how can you decide where do you want to buy, where do you want to sell? So basically, in some sense, you can only have two states while you are going through the array. Either you are already holding a stock or you are not holding a stock. And it is given to us that at max you can only hold a single stock. So whenever you are at the hold state, you can't hold any more stocks. So you can't have a decision where you want to hold another one and you go in a different state. So from the hold state, you can either go to the not hold state or you can decide to not buy the stock and keep staying in the same hold state. And in the not hold state also, you can either sell the stock when you have not already sold it yet, or you can actually buy another one. So you can either go in the hold state by buying another stock, or you can just stay here where you haven't bought anything, or maybe have sold something in the past and don't want to buy anything anymore. So these are your two conditions. So let's write them out nicely as a state representation. So you have your two states, which is your hold and your not hold. If my writing is understandable, I hope. And you can either go from hold to not hold or from not hold to hold. So to go to hold from not hold, you will actually have to buy a stock. So that will be uh, getting out of your profit. So you are actually paying money to buy something. So your overall wallet is decreasing. And whenever you're going from a hold to not hold state, your profit is actually increasing because you are selling something away and you are getting money from it. And that's it. So that's your problem. And from hold, you can either remain in the same state, and from not hold, also you can remain in the same state. So at each point, you have a decision to make, and that decision depends on your previous state. So if you are in a hold state, you can either decide to sell the stock or you can decide to keep holding it. And if you are in a not hold state, you can either decide to buy a stock or you can decide to not hold any stock even longer. So those are the two decisions you have to make while you are traversing the whole array, and that's your problem. So that's your state diagram. And if you have done reinforcement learning in the past, or if you're familiar with state machines, this state diagram must be very familiar to you. But basically in the state diagrams, you have the different actions you can take and the different states you can reach using those actions, and you have to just basically model what your problem looks like, what are the different dynamics of your problem in some sense. So yeah, this is your problem, and how can you go about doing that? So while making these decisions, we have to take care of the maximum profit we have earned till now in both of the conditions, by either holding a state or by not holding a state, so that we can later decide if we want to continue holding or not holding our profits. So to do that, we basically want to maintain at each step our previous holding profit and previous not holding profit, which will store the maximum profit we have seen till now while holding a stock and the maximum profit we have seen till now while not holding a stock. So uh, we also have to initiate them to a particular value. Now the initiation will make sense once we understand the whole problem, so we can discuss it later. But for now, you can think that these two things hold the maximum profit you can earn till now by holding a stock or by not holding a stock. And at each state later in your cycle after the initiation, you just want to check that if you are previously holding a stock and you sell it at this point, what will be your max profit in the current not hold state. And if you are in a state where you have not holding a stock till now and you buy the stock, what will be your profit in your current hold state? And you have to maintain both of these different states, because in each decision you want to see both of the different scenarios, you want to see both of the approaches, whether if I was holding a stock from before, would that have made me profit here, or whether I was holding not holding a stock before, if buying a stock here will actually help me. So you'll have to maintain these two variables throughout your array and see in each cases, making them go from one state to the another to see that what is the maximum profit you can attain at the end of your whole array. So I hope the state space and the dynamic of the problem makes sense. I think it will make much more sense when we actually code it up. So without any further wastage of time, let's go back to our code, reset this and confirm, because we don't want any code from the previous part. We are solving it as a dynamic programming problem. And here we are just gonna instantiate our two values, which is current hold and current not hold. Now, if we are not holding a stock, it makes sense that our profit will be zero by now, because we haven't done anything yet. We are just sitting there and we haven't done anything. It's just the same as paper trading. You are just looking at the stocks for no apparent reason and wasting your time and resources. And the second case, when you are holding a stock, what should we instantiate it to? Now, we just said that we want to maintain our hold and not hold states and see what the maximum profit is that we can achieve. Now, whenever we are trying to go in a hold state from a not hold state, which is going to be our initial value, we are losing money from our pocket, because we are paying to buy a stock, and that way we always end up in negative profit. So if we want to instantiate the hold value to zero, it will cause a problem that we'll never want to buy a stock throughout our own cycle, because we will never just buy anything. We'll see that it goes to the negative value, and we'll not be able to look up the future profit that we can get from it, because we are only going through each stage and making a decision there based on the immediate previous state that we were at, which was our maximum profit till now, and we will just end up returning zero in every case. So we want to return a previous hold value to something that actually allows us to buy a stock, and buy any stock for that instance, because we don't know what the future holds for us. Maybe there's extreme profit from that particular value, which seems to be very high now. So how can we do that? We basically just want to instantiate this current hold value to the least integer value that is available on Golang. And to do that, you can just import your math library, uh, which you can do like this. And then you can just say math dot min int 64 to get the minimum integer value you can get in Golang. And while you are maintaining this, you want to traverse your array, which again will start at 0. You will go till you traverse the whole array this time, because at the last step also you will have to make the decision whether you want to buy or sell the stock. And finally, we'll end up returning the value for not holding state, because we know that when we are done with the array, we don't want to end up holding any stock with us, because that's just gonna cost us extra money. That's a liability at that point. We want the maximum profit. So that's why we'll traverse through the whole length of the array, and we'll increment by 1 at each step. And what we are going to do is we're going to see that if we are at the current hold state, first of all, we want to also maintain our previous hold and the previous not hold states. So first, let's write that down, that we're going to maintain another set of variables, which is going to be previous hold, and it's going to be the current hold value, which we have right now. And the same way, let's just write it down in the same assignment, that our current previous not hold is also going to be, and current not hold. Sorry for that. Yep. So these are going to be our instantiating values, and I think in some sense we are never instantiating previous hold and previous not hold. So should we instantiate them separately, or how would that go? I'm actually not sure how can we do that. So I think maybe we need to instantiate our previous hold and previous not hold, because that's what we need. And the current hold and current not hold we will actually calculate. So we'll store the current hold and current not hold values in our previous hold. But before doing that, we want to actually see what is our current hold and current not hold, and we'll get them using the conditions that we just discussed. So before doing that, we actually want to keep the maximum value. So for that, let's define another function which is going to store the maximum value for us. So let's define a function max, which is going to take in two values. So value 1 and value 2, which is both going to be integers in this case. We don't need to use that. That's a Python thing. And we also want to return an integer. And we are just going to check that if our value 1 is greater than our value 2, we're going to return value 1, or else we just want to return value 2. So that's our function right there. And this will allow us to quickly get the maximum value, and the comparison will be comparatively straightforward. And when we are in the current hold state, if we want to see that do we want to be in the current hold state or not, we are just going to check that what is the maximum value among our previous hold state, uh, and what and value if we buy at the current state. So if we end up buying in this particular state, so if we are buying something, we are actually subtracting it from the profit. So we will be in the previous not hold state, and we are going to subtract our profit, so which is our, again, it's not nums, it's prices, and we are going to subtract our prices of I. And in the other case, when we want to see if we want to be in the not hold state or not, we will see that, and this is going to be an assignment. So for our current not hold, we are just going to check that what is the max value between our previous not hold and us buying it now. So we have been not buying it yet. Sorry. So previous current not hold is gonna come from selling actually. So we're gonna check that what is the profit we get from not holding it previously, and what will be the profit we get if we sell it now. So we want the maximum among each of them. So if we had sold it previously, or if we are selling it now, which one is more profitable? That's what we are keeping a account of in here. And finally, we just want to return our previous not hold value, because that's your final profit. That's what you're gonna finally have. Yeah, I hope this makes sense. Let's try to run this to see if it's working or not. I hope the explanation and the code is aligning. Okay, we are missing import path. Oh, we are using these braces. We actually have to use the normal parenthesis, or not curly braces in this case for Golang. Uh, this is coming from JS, by the way. I don't know why I'm programming in so many different languages, but here you go. And let's just try running this. And we have a shit ton of errors because we didn't assign this. Oh, so let's run this again. Cool. So the solution is accepted. You can see that all of the test cases are running, and let's try to submit it. I'm not sure if we'll get any runtime or memory advantage from this, but our goal was to understand dynamic programming. So yeah, our memory is slightly less efficient because maybe we are using 4 different variables now, whereas in the previous one we were only using a single variable. But yeah, that was not the goal. The goal was to understand how you can fit DP to problems that are actually overlapping sub problems. So if you see the problem again, you can see that it's clearly a overlapping sub problem, where if I give you the array till here, you can tell me what's the maximum profit you can achieve till here. Then I give you the array till here, and you can tell me that what's the maximum profit you can achieve now given any other element in the array. And you can keep adding those values in the array, and your values will keep on changing based on that. So it's just basically overlapping sub problems, and DP is the recipe when it comes to sub problems that are overlapping. And that's why I wanted to show you how you can fit DP in such simple problems and see what results it gives you. And I hope the problem makes sense, and also the state diagram that we built to understand this problem. And that was basically it. So you are basically maintaining a hold state and a not hold state, and you are basically doing bookkeeping at each step, maintaining the maximum profit you have seen till now. So hope everything made sense, and enjoy. Just try to take some time with this code. It's a bit tricky to understand because it doesn't make sense why we are comparing current hold with the previous hold and the previous not hold minus prices, because we thought we are deciding of buying when we are doing current hold, and that's what confuses people. But actually you have to understand that you are comparing the value that if you had previously held the stock, what was the maximum profit you were getting, and instead of that, if you were previously not holding the stock and you are buying it right now, what is the profit you can get. So current hold actually holds the value of maximum profit between holding the stock in the previous state and holding it right now, so which is the better state to buy. And the same thing with sell. So yeah, that's the explanation. I hope you enjoyed the video and you enjoyed both of the solutions. I don't think many people go in the second solution for this problem, so leave a like for that if you want to. There's no pressure at all. But yeah, that's the end of it. See you next time. Bye bye.